Water is essential for all forms of life on Earth. It covers over 70% of the Earth's surface and is a critical component of living cells. But there is one specific property of water that often goes unnoticed, and most fail to realize the importance of this one small but very significant detail. This basic property of water is unique from essentially all other compounds on Earth and makes life as we know it possible. In fact, I distinctly remember the importance of this property being pointed out to me years ago during one of my college chemistry classes, and after the professor described it to us, I very clearly recall him mentioning that water having this unique property was no coincidence, and that those in the class questioning the existence of God should especially take note. When a solid piece of a substance is dropped into its liquid form, that solid piece will sink to the bottom of the liquid in essentially all cases. This is because, for almost all substances known in nature, they become more dense when they transition from a liquid into a solid. But as we all know, that is not the case with water, as ice floats to the surface of lakes and oceans instead of sinking. This is because water is one of the only compounds known on Earth that is denser in its liquid form than its solid form. And it is this small but unique detail about water which enables life on Earth to thrive. But what if water was like almost all other substances and ice sank in lakes and oceans instead of floating? This scenario would have profound implications for the existence of life on Earth. Are you finding this hard to believe? Well then, let's review some examples of how drastically life on Earth, if even possible, would be different in this scenario. Catastrophic earthquakes and volcanoes would be much more frequent on Earth, attributed to the implications on Earth's geology. The specific reason for this is movement of water plays a critical role in shaping the planet's surface. Rivers erode and transport sediment, creating unique landforms and habitats. The movement of water also helps to regulate the Earth's tectonic activity. One way in which water affects tectonic activity is through its role in lubricating faults. A fault is a fracture in the Earth's crust, and when plates move past each other, friction can build up along the fault line. This friction can cause the plates to become stuck, creating tension that can eventually lead to an earthquake. However, when water is present in the fault zone, it can act as a lubricant, reducing the friction and allowing the plates to move more freely. This can prevent the buildup of tension and reduce the likelihood of a major earthquake. One example of this is the San Andreas Fault in California, which is one of the most well-known and active faults in the world. This fault marks the boundary between the Pacific and North American plates, and its movement is responsible for many earthquakes in the region. However, scientists have found that water is present in the fault zone and may be helping to lubricate the plates and reduce the likelihood of a major earthquake. But if water was more dense in its solid form, its flow would likely be disrupted in many locations, inhibiting the lubrication of these plates. Additionally, this would prevent sediment movement, affecting the shape of the landscape and leading to many more frequent catastrophic earthquakes and volcanoes throughout the world. The Earth's climate would likely be in turmoil compared to the comfortable and consistent environment we currently experience. Frequent disruptions in weather patterns would be experienced every year, leading to potentially catastrophic consequences for the planet's ecosystem. For example, the formation of sea ice would be significantly impacted as seasons alternated, leading to vast changes in the salinity and the temperature of the ocean. These changes would influence the movement of ocean currents and the exchange of heat between the atmosphere and the ocean, leading to cascading effects on the planet and causing widespread extinction of many species. Bodies of water would freeze from the bottom up, making it very difficult for aquatic life to survive. One reason is the top layer of insulation typically provided by ice would be absent, leaving the aquatic creatures exposed to much colder water temperatures. This would result in massive die-offs of aquatic species, disrupting entire ecosystems and causing irreversible damage. In fact, these conditions may have been so bad that the existence of aquatic life may not have even been sustainable in these type of environments. Now, this goes without saying, but the impact on humans would be significant. Water is a critical resource for human survival. We rely on it for drinking, agriculture, and industry. But the sinking of ice would significantly affect the global water supply. The movement of ice from the poles to the equator not only helps to regulate global climate patterns, but it also assists in providing fresh water to areas that rely on glacial runoff. If ice were to sink instead of float, it would accumulate at the bottom of bodies of water, reducing the amount of fresh water available in many parts of the world and exacerbate drought conditions. Additionally, the sinking of ice will result in many lakes and rivers freezing over completely, further reducing the water flow and supply in many regions. It would also have a significant impact on agriculture, making it difficult to grow crops. This would lead to widespread famine as communities would struggle to access not only water, but other essential food resources throughout the year. So at this point, it should now be clear to you just how this one basic but unique property of water has been a critical factor in the habitability of our planet. If water was more dense in its solid form, the implications for the existence of life on Earth would be significant, and the delicate balance of the Earth's ecosystem would be disrupted, potentially making the planet uninhabitable for many species, including humans. In fact, an argument could even be made at this point that if water did not contain this unique property, and ice sank in liquid water like essentially all other solids when placed in their liquid form, life as we know it may not have even existed on Earth. So out of all compounds known to exist in nature, how is it that water just so happens to be one of the select few to contain this unique property that is essential to life thriving on Earth? In my mind, the answer to this question is obvious, and that is when God created the Earth, He knew exactly what the implications to life would be if He had made water the same as any other compound. He knew right away that water needed this one unique difference for life to be sustainable. This would certainly be the more plausible explanation, right? I mean, wouldn't it be crazier to believe that this was just a lucky coincidence? Or maybe what we all need to do is just pay a little more attention in our science classes and take better notes. But I'll leave that one for you to decide.